Hello everyone, and welcome to lesson 8.4, which is factoring with a GCF. Now, in our previous lesson, we talked about how to find GCFs, greatest common factors between two numbers. We're going to use that as a super helpful tool to factor problems today. We're going to look at two separate things in lesson 8.4 today. We're going to look at number one, how do we factor GCFs using coefficients and variables, how to handle both of those. And then the second thing that we're going to look at is how to solve equations where we have to take a GCF and looking at a property that comes with that. So, to factor using a GCF, the first thing that we have to do is take the GCF of the numbers or the coefficients, however you want to call those. That was the process we described back in 8.3. The second step is to take the greatest common factor of each set of variables separately. So if a problem has x's, y's, and z's in it, then we have to take the greatest common factor of the x's, then the greatest common factor of the y's, then the greatest common factor of the z's. The third step is to write all of our greatest common factors for our coefficients and each independent variable together as one answer. And if we happen to have anything left over, we're going to write that as a group in parentheses. So then we pull out and divide out, because remember, taking greatest common factor is division. We divide out all of our greatest common factors, and we have that term out in front, and then our leftover pieces is what's going to be written inside parentheses. All right, so let's go ahead and take a look at how to take greatest common factors using coefficients and variables, and we'll go from there. So the first thing that we have to look at here in number one is kind of what we've talked about all along in chapter 8, is we're treating each part separately. So we are going to look at our coefficients. And in this case, our coefficient is 5 in both terms. So what is the greatest common factor of 5? Well, that's going to obviously just be 5. Now, we're asked to find the greatest common factor between x squared and x. And I'm going to highlight that in green. So now we have x squared and x. Well, we have to understand what we are saying, right? X squared, we know, is really just x times x. So we have two x's next to each other there being multiplied. And we know that the x is just one x by itself. So when I'm trying to take the greatest common factor of variables, if I look at the problem or the variables this way, how many, or what's the most amount, the largest amount of x's I can take away from both terms at the same time? Well, the largest thing I can take out of both terms at the same time is an x, because I have one x in the second term, and then there's an x that I can take away in the first term. So taking out that x, that gives me my greatest common factor, and the remainder piece is just written inside. So our first term, we have x, and our second term, we just have 1 because we were actually able to factor out everything. And remember, in factoring, we are dividing. So when we have our term, it's broken down as GCF on the outside, leftovers inside the parentheses. And every time we factor, we get this. Okay, so now let's say that you have factored and you think you've done it correctly. Can you possibly check your work? Yes, you can. You can take your answer, and we've seen problems like this before. To check, we just multiply, because multiplication is opposite of division. So factoring out, the opposite of that is actually doing distributive property. 5x times x is 5x squared, plus 5x times 1 is 5x. And if we look, when we check our answer, we're back to where we were at the beginning. So, in the beginning, as you are trying to factor terms, if you mess something up, you can always check it to make sure that, oh, I forgot to put a 1 here, because some people might not have put anything for that second term. But remember, factoring is division, so we factored out the 5 from both terms, we factored out one of the x's from both terms, and that left me with 5x as my greatest common factor, and then x plus 1 on the inside. Okay, looking at our second example here, we are going to start with our coefficients, our numbers. We have 9 and 3. What is the greatest common factor between 9 and 3? Well, the greatest common factor between 9 and 3 is 3. Now, we look at our variables. Looking at our variables, we have y to the 4th and y to the 3rd. Taking a look there, remember y to the 4th is y times y times y times y. Y to the 3rd is y times y times y. So how many y's can I take out of both parts? The answer is 3. Because if I take out 3, there's 1, 2, 3 here. 1, 2, 3 there. So I've taken that out. On the inside, 3 times 3 is 9, and then we still have that y left over because y to the 3rd times y is y to the 4th, minus 3 times 3, or 3 times 1 is 3, and y to the 3rd times 1 is y to the 3rd, and so now I have factored that out. So, again, if I need to check my work, I can check that. 3y to the 3rd times 3y minus 1. We do a little distributive property to check. 3 times 3 is 9. Y to the 3rd times y is y to the 4th. 3y to the 3rd times 1 is 3y to the 3rd. And if we look, this answer is exactly where we started. So, the process for taking greatest common factors is twofold. One, we want to take the greatest common factor between our coefficients, and that's dividing out. The second piece is taking the greatest common factor between the variables. Typically, as a general rule, it's always going to be, I'll put this in gray, it's always the lowest exponent is what we end up factoring out. So it's the largest number we can take out of both terms, and then when you're comparing all of your variables, it's the one with the lowest exponent. If you look in the first one, the lowest exponent was x, and that's what we factored out. Here, the lowest exponent was y to the 3, and again, that's what we happened to factor out. So if you wanted a shortcut, there's a pretty decent one. All right, number 3. In our third example, we have negative 4a to the 3rd minus a squared. Now, the reason that I wanted to include this problem is because of the negative that's leading out. Anytime you have a negative leading out, you have to factor out the negative. So, when I'm looking at this problem and I say, hey, I'm comparing my numbers, which if I'm comparing the numbers, I'm comparing negative 4, and even though it's not written, we've said this over and over, there's technically a 1 there. And so I'm trying to factor out the greatest thing that I can between negative 4 and negative 1. Well, the largest thing that can go into 4 and 1 is just 1, but since I'm taking the negative as well, on my coefficient side, my greatest common factor is a negative 1. When I'm looking at my variables, right, a to the 3rd is a times a times a squared is a times a. That means I can take 1, 2, 1, 2 out of both. So negative 1a squared is my greatest common factor. And now I'm just concerned about writing what's in the parentheses. So negative 1 times 4 gives me negative 4, a squared times a gives me a to the third. Negative 1 times a positive 1 gives me negative 1. And then a squared times 1 is a squared. So my final answer here is negative 1a squared parentheses 4a plus 1. Or if you wanted to write it like you would see it in a book, you would get negative a squared 4a plus 1. All right, so again, we've just divided out and we've had our leftover pieces, right? So in this problem, we factored out the negative for our number part. For our variable part, we were able to factor out a squared. The leftover pieces on the inside are whatever's left over, so that's a 4 and an a for the first term, and then just a 1 for the second term. And that's how we handle factoring both numbers and exponents. And it works like that every time, no matter what. Just remember, and I'll put this in red, star, factor the negative. Okay, like that's a big deal. Okay, so now we're going to look at the second part of this lesson, which is solving equations using a greatest common factor. Anytime we are able to factor, we're going to need to do that. And the reason why is because as we have exponents with larger and larger numbers, so higher exponents, we're going to get more answers. We're going to have multiple answers, 2 and 3 separate answers for x. And that's okay as we're going more into our world of quadratics here in Chapter 8. But there's a special property called the zero product property. And what that property says is that after we factor, we can take each of our parts and set each part equal to 0. So as we've seen in this lesson, we've had a greatest common factor part and we've had a leftover part in parentheses. We can take each of those parts, set them equal to 0, and solve. That's going to give us multiple answers, which is totally acceptable. So let's take a look at our examples here. Our first example is 6x times x plus 4 equals 0. Now, this problem is already factored. We see we have our greatest common factor on the outside. We have our leftover piece inside the parentheses. So according to the zero product property, all we have to do is take the 6x and set it equal to 0. Then we take the inside piece, which is x plus 4. We set that equal to 0 too. Now we have two small problems, and all we have to do is solve those. So x is equal to 0 in the first part, subtract 4 over here, and x is equal to negative 4 in the second part. So our answer for number 1 is that x equals 0 and x equals negative 4. Both of those answers are acceptable, and we get that by using the zero product property. Okay, in number 2, we have negative x to the fourth minus 2 x to the third power. So whenever we go to take our powers or our greatest common factor of our numbers, remember we're factoring out negative 1 and 2. What's the greatest common factor there? Well, the greatest common factor between those two is just negative 1. We have to take that negative, remember. And then when we're looking at our variables, remember x to the fourth is 4x's, x to the 3 is 3x's. How many can I take out of both parts at the same time? Well, 1, 2, 3, 1, 2, 3. So then my greatest common factor there is negative 1, x to the third. What's left over? Well, negative 1 times 1 is negative 1 for the first term. X to the third times x is x to the fourth. And then we have negative 1 times 2, and that's a positive 2, is negative 2. And x to the third times 1 is x to the third, so we don't need to put anything there. And now we have our factors. We have negative 1x to the third times 1x plus 2. Just as we can remember, right, we don't ever include these ones in things, so we just say negative x to the third and x. All right, so as we go to solve this, now we have our problem that we can use our zero product property on. Zero product property says we take our first thing, negative x to the third is equal to 0, and x plus 2 is equal to 0. Well, to start here, we know that what to the third power is going to be 0. That's just 0, right? So 0 times 0 times 0 is 0. That's an easy one. Anytime we get just a variable with any kind of exponent and it's set equal to 0, the answer is 0. And then in our second one, we know what to do. Just use opposite operations to get negative 2. And we're able to solve that. All right, number 3, we have x squared minus 4x equals 0. Looking here at our coefficients. Our coefficients, again, we have a 1 and we have a 4. What's the greatest common factor of those? The greatest common factor is 1. Then with our variables, our greatest common factor, we have x and just 1x. The most I can take out of both is just one of those. So that essentially just leaves me with 1x, as we've covered multiple times. If it's a 1 out in front, we don't even need it there. So x times what is x squared? X times x is x squared. And then minus x times 1 is, x times what is 4x? And the answer is 4. X times 4 is 4x. Now that's equal to 0. Now, once we're factored, we can use the zero product property. The zero product property says that I can take x and set it equal to 0. I can take the x minus 4 and set it equal to 0. The first term is already done for us. The second one, we add 4 to both sides, and x is equal to 4. And that's how we solve equations using greatest common factors. So guys, I think the zero product property piece is going to be the easier of the two pieces when solving these equations. It's consistently being able to take the correct greatest common factor, right? So you've picked up tips. It's going to take practice to get this down. It's not just going to be an immediate thing that everybody gets right the first time. Please, take a look at that, sit on that for a little bit, look at some examples, work some extra problems. If you have any questions, whether that be on the zero product property and solving equations, or if it's just on taking the greatest common factor, I know that you've seen this before in earlier math, but even though we've talked about taking greatest common factor in this chapter, it's a big, big piece that we got to get right. So if you're struggling on this, if you have any questions, please reach out to me and let me know.